Assalamualaikum warahmatullahi wabarakatuh. Hello, everybody. For today's video, we will be discussing about the limit of trigonometry. So, in this video, we will start discussing about the limit of trigonometry. But but for the beginning, we would not we would not discuss directly to the limit of trigonometry. So, before we are diving into the limit of trigonometries, we will review some trigonometric identity. Because for trigonometric limit, what is it? Uh, when we're talking about trigonometry limits, it is uh, actually the limit of trigonometry is just you're doing some manipulation on the limit, just like you do in algebraic limit. So if you have function that is algebraic or polynomial, to solve it, when you have 0 divided by 0 result, when you're plugging in the value of the x, you do some manipulation there. Now, for limits, trigonometric limits, you do the same. You do the same thing. You do some manipulation, but the difference is that we deal with with trigonometric function. So to do some manipulation on trigonometric function, we need to know the identities. So we have to know the identities. Otherwise, we would not, we can't solve a limit, trigonometric limit. So that is the key, the key idea why we have to review some identities in trigonometry. Now, I will not review it from the very basic, such as might be example like uh, tan the tangent tan x is equal to sinus x divided by cosine x. No, I will not review the most basic identities in the trigonometry, or maybe such as like secant theta is equal to 1 over cosinus theta, or maybe some basic trigonometric identities such as 1 over cosine of theta is equal to secant theta, or other basics identities that you might have learned in elementary schools, in the previous course in the analytical trigonometry. So I would not discuss the very basics. I'm gonna start at the more advanced trigonometric identities, such as the sum of sine, the sum of cosines, the sum of tangent, the subtraction formulas, the half angle formulas, and other formulas that you have learned in the analytical trigonometry in the 11th grade. So if you still struggling on remembering the basics formula, such as like was stated earlier, such as sinus squared x plus cosine square x is equal to 1, such like that, you could go back to your previous courses in the 10th grade. Otherwise, you can continue to this video. If you have learned about it, if you have learned the most basic identities in the 10th grade, you can continue and watch my video here to discuss further about the trigonometric limit. Now, let's start the review. So, I'll I'll write the title for this course, for this video: trigonometry identity, trigonometry identity review. So review. We're gonna do a review. So because I'm doing a review, I will not give you the proof, the proof of the video of the formula. You can search it on by yourself and on Google. Because this is only a review, only I will only tell you about the identity, but I will not giving you a proof for the identity, because we will discuss a lot of identity. You much of them you can find it on Google, the proof. So I think it would be time spending if we discuss the identity followed by the proof. So I will not include the proof in the video. So the first the first identity that we have to remember is, what is it? So the first one that we should be remembering again is the sum and subtraction of sign, yeah, of signs. So uh for example, the first one is, if you have sinus x plus y. If you have sinus x plus y, you could some sort of expand this. Yeah, we could expand this into sinus x, sine x times cosinus y, plus sine plus cosinus x times sinus y. So this is a very basic of the sum of sinus. And then for the subtraction of sinus, okay, maybe we will include the sum and subtraction of sinus, cosine, and tangent also, because the three of this function are in the same pages. So it's the same pages, because it also deal with sum and subtraction too. The sum and subtraction of a function. So I think that uh, it would be more wise if we include sinus, cosine, and tangent in one course, in one subtitle. Okay. Okay, let's continue. The first is the now, if we have sinus x plus y, we could expand this into sinus x cosinus y plus cosinus x times sinus y. So you see that there's a pattern here. So you put the sine for x, and then you put the cos to y, and then for the second term you put the cos in x, and you put this y, you put the sin on the y. So it just so it's a pattern that we can see. It's a pattern that we can see. So if we if I change it into the sinus of x subtract by y minus y, you can see the pattern are also the same. Sinus x first, then cosine of y. But the term here, the term here changes from positive into negative. So negative cosine of x sinus sine of y. So there's a pattern here. Now, if I want if I want the y is equal to x, it is just the same as x plus x. And we could solve that, we could simplify that into 2x. So sinus 2x, that's a that's a double sinus. That's a double sinus formula. Maybe we will go through that later, but this is also, this is just an information that we will talk about it later. But it's an idea to how to get the double sinus formula. Okay, okay. We'll talk about it later. We will discuss about it later. We'll move on to cosine first. Cosine. So let's move to cosine of x plus y. So for the cosine, we write the term cos. We write the term cosine first. So cosine x, cosine y minus, yeah. So it's a different. So it is kind of unique, yeah, because for the plus term, yeah, you use the subtraction term here. You use the subtraction operation here. So kind of different. It's a pattern that you could remember in case you forgot about the function, forgot about the identities. So the cosine of x times cosine of y minus sinus x sinus y. It is the identity. And for subtraction, cosine of x minus y, to expand it, we just change the operation here from from subtraction to sum to plus. So we could change it cosine x cosine y plus sinus x sinus y. So this is an important things to note it. Okay, this is for the for this for cosine. Move on to tangent. So if we have tangent x plus y, we could expand this to tangent x plus tangent y. So you write the sum of tangent first, tangent x plus tangent y, divided by 1 minus 1 minus the product of the tangent. So tangent x, tangent y. So it's a pattern that you can see. For the first term, for the up term, for the above term, you write the sum of the tan, because why the sum, not the subtraction term? Because this is a subtraction, this is a sum formula of tan. So we write the sum we write the sum term first, and then we write the below term with product term. Okay, so it's C is a pattern. And what will you do if for subtraction, tangent x minus y, it would be equal to the the subtraction of tangent. So tangent x minus tangent y divided by 1 plus, so the term changes here, the operation changes from minus to positive. So 1 plus, still the product rule. So still the product of the tangent, tangent x, tangent y. So the only difference here is only in the operations. We change it from positive to negative in the above term, and for the below term, we change it from negative to positive. So it's a pattern that you can see, right? Now, uh, okay, continue. Let's continue. So we have discussed about the sum and subtraction of sinus, cosine, and tangent. This is the formula that you have to remember. And then what if you want to search, what if you want to know about the double angle formula? So what if you want to know the double angle formula? Double angle formula is like sinus of 2x, tangent of 2x, cosinus cosine 2x. Yeah, so that kind of form. Now, what if we want to know the double angle formula? So we could achieve it from the sum and subtraction formula. So, for example, for some double angle, I'm sorry, not angel, angle, for sinus, for sine, if you want the double angle formula, the sine of 2x, well, 2x is just the same as x plus x, right? So we could use this sum formula. So for the original formula is the sine of x plus y, right? So we change the y into x. So the sine of x plus x. So if you have sine x plus x, you have sinus x. So if we expand the sinus x plus x, we have sinus x cosine of x plus cosine of x sinus of x, right? So sinus x cosinus x plus cosine of x sinus of x. So for the double angle formula, these terms become equal. These two terms become equal because they are both equally sinus x times cosine of x, right? This term is sinus x cosine of x. This term is also sinus x times cosine of x if we arranged it a little bit. So if we sum it, if we uh, if we if we edit this both term, it becomes 2 sine of x cosine of x. This is the formula for double angle. Okay, we get the double angle formula. What if we want to search the cosine of 2x? Double angle formula for cosine. Again, we can use the formula that we had in this particular formula for the subtraction and for the sum formula. So if we have cosine of x plus y, it will be equal cosine of x cosine of y minus sine of x sinus y, right? So if we change the term y into x, so we have cosine of x plus x, it will be, if we expand it, cosine of x minus sinus x sines x, so it will be cosine x squared, right? It will be cosine x squared minus sine x squared, right? Because sine x times sine x just the same as sine to the power of 2x, sine 2x, okay? Not 2x in the angle, but 2 in the power. So sine x to the power of 2. So cosine of x to the power of 2, right? So this is the formula. Or using other identities, what in by okay. So if we got the formula cosine squared x minus sine x squared, cosine x squared minus sine x squared. And by using another identities, by other identities, what I mean is sine x squared plus cosine of x squared is equal to 1, you could get another formula, which is which is 1 minus 2 times sin x squared, or 2 cosine of x squared minus 1. So this is other formula for the cosine. Okay, and you can also change this particular double angle formula for certain circumstances. For example, if you want to expand the cosine of 4x, we could get that the identity could be cosine 2x squared minus sinus of 2x squared. So you could see the pattern here. If we have 2x, the expand term will be only x. If the cosine of 4x, the term is 4, the left term is 4, then the right term will be the half of it, the half of the initial term, the initial coefficient of x. So the initial coefficient for x is 4. Then for the left hand side, you write the cosinus, you write the term with the half of the initial term, the initial coefficient. So the half of 4, of course, is 2. And you could also expand this into 1 minus 2 sines 2x squared, or you could also rewrite it as 2 cosine 2x squared minus 1. Another example, if you have cosine of 5x, you could also expand this into cosine 5 per 2, 5 over 2x squared minus sine of 5 over 2x squared. Or you could also expand this as 1 minus 2 sine 5 over 2x squared. Or you could also expand this into 2 cosine of 5 over 2x squared minus 1. So this identity could be changes according to the circumstances that you have. Okay, so this is a very interesting, this is a very interesting fact. And sometimes this is the thing that students forgot, that you can change, you can modify the formula that you had. So it is also the same for the double angle for the sine. So you could search sinus for x into 2 sine of 2x cosine of 2x. This is for the 4x. You could also expand the sine of 5x. So you could expand this into 2 sine of 5 over 2x cosine of 5 over 2x. Right? Okay? I think it's clear. Okay? Now for the tangent, for the tangent double angle formula, we could expand this. We could use the formula in the beginning that we had, which is tangent of x plus y is tangent x plus tangent y over 1 minus tangent x tangent y. So we if we change the y term into x, we could get the tangent of 2x is equal to tangent 2 tangent x divided by 1 minus tangent x squared. Okay, if I'm not mistaken, that's the what the formula. Okay, and again, you could expand this, you could change this formula based on the circumstances in the question, in the problem. Okay, this is for the double angle formula. I think that's enough for the double angle formula. Okay, let's move on to the half angle formula. So what is the half angle formula? It has a similarity actually with the double angle formula. So if for the double angle formula, you write the left you write the right term with the half, with the angle is the half of the initial angle. Now for the half angle formula, for the left for the half for the right term, for the right hand side, you write the degree, you write the angle double to the initial, formula. So for example, if the most basic, the fundamental formula is the sine of x, the half of x, it will be equal to the root of 1 minus cosine of x divided by 2. But you can modify this formula into sinus x is equal to the root of 1 minus cosine 2x divided by 2. So you see the pattern here that you could change the formula based on the circumstances that you had, but the difference between this half angle formula with the double angle formula, for the double angle formula, you write the right hand term, the right hand side, with the angle that you chose is the half of the initial angle, the half of the initial angle. But for the angle formula, half angle formula, you write the right hand side, you chose the angle with the double of the initial angle. So if you choose x divided by 2, then the double of it is equal to x. If you choose sinus of x, the double of it will be cosine of 2x. Okay. Now, for the cosine of x divided by 2, the half of x, is equal to the root of 1 plus cosine of x divided by 2. And you could change this equation, you could change it based on some circumstances, based on your circumstances. For example, you have cosine of x, you could expand it as 1 plus cosine of 2x divided by 2. And the third, for the tangent of the half of x, it would be the root of 1 minus cosinus x divided by 1 plus cosine of x. But as you could write this as the sinus of x divided by 1 plus cosinus x. Also, you could write this as 1 minus cosine of x divided by sinus x. This is for the half angle of the tangent. Half angle for the tangent line. Okay. Okay, that's for the half angle formula. Move on to the product rule. Product rule. Product identity. Maybe that's more suitable. Product identity. So for the product identity, actually it's just the same with the previous identities, but I will still tell you about it. So if you have the two sinus alpha cosine of beta, you could expand this into sinus sine of alpha plus beta, or maybe I will write using other term Greek letter are kind of confusing, so I'm just gonna switch into x and y. So 2 sine of x times cosine of y will be equal to sine of x plus y plus sine of x minus y. This is the product identity, the first product identity. Second one, if you have 2 cosine of x sines of y, it will be sine of x plus y minus the sine of x minus y. Fundamental, okay? This is the product identity. And then if you have 2 cosine of x, cosine of y, if you expand this, it would be cosine. It would be a cosine of x plus y plus cosine of x minus y. And then for the last one, if you have 2 sine x sine y, if you expand it, it would be minus cosine of x plus y plus cosine of x minus y. This is for the sine formula, sine product. Okay, this is the product identity. This is maybe I will change this title, this subtitle, from sum and subtraction of sine, cosine, and tangent. I will change it into sum and subtraction angle of sine, cosine, and tangent. Now, move on. We are going to discuss the product, the sum for sum and subtraction, trigonometry, trigonometric function. So in the previous talk, we talk about the sum and subtraction in term of the angle. So the angle is being either sum or being either sum or being subtract. Okay, that's for the A part of this review. Now for the E part, the sum and subtraction of trigonometric function. So the difference between the A part is that the function is being summed, not the angle. Okay, so what we do in the previous is summing or subtractioning the angle. But in this E part, A, B, C, D, E, yeah, E part, for the E part, we will be subtracting, and summing the function. So, for example, if you have sinus x plus sinus y, it would be equal to it will be equal to 2 sine of x plus y divided by 2 cosine of x plus y divided by 2. And then for the subtraction, sinus x minus sinus y, it would be 2 cosine of, this is not x plus y, x minus y. So x plus y divided by 2 sine of x plus y divided by 2. Again, not plus, this is minus, x minus y divided by 2. Now this is the sum and subtraction of sine. What if the cosine? what is the term for the cosine? What is the expanding term for cosine? So if we have cosine of x plus cosines of y, you would get 2 cosine of x plus y divided by 2 cosine of x minus 1 x minus y divided by 2. And then for the subtraction, cosine of x minus cosine of y, there would be 2 minus 2 sine x plus y divided by 2 sine x minus y divided by 2, x plus y divided by 2, x minus y divided by 2. So you could see the pattern here, okay, from the sum and subtraction of trigonometric function. Now, uh, we use this a lot. So we use this sum and subtraction function a lot. So I suggest that you remember these identities, and of course, the other identities you should be remembering it again. You have to, well, there's nothing that you can do, and there's nothing that you can do other than memorizing this term, this formula, because if you don't remember it, it would be difficult for you to take to work on trigonometric function, like the limits of trigonometric function. So I think that's it for the trigonometry identity review. That's all. I hope you remember this function, these identities, all of them. You're not really have to memorize all of them, because you can see there's some pattern of these identities. So I hope that because there is a pattern on the identities, you could memorize it more easier that rather than memorizing it one by one without remembering the pattern. So I think that's all for today. Thank you for watching my video. Assalamualaikum warahmatullahi wabarakatuh.